You see the camera, right? So your limit here, right?
My
can
limit
further,
is okay. Yeah. My limit, right?
Because with that, it's tempting to. Oh, we're online. Hey, good morning, everyone. Morning. What a beautiful day here in New York. I don't know online in your own towns everywhere in the world how it is, but we're having a sunny day here in New York. So yeah, I'm glad it's the fourth day of KGC this week. Very good presentation. And today we're having the keynote of Ora Lassila, a long-term practitioner from Amazon Neptune. So Ora, the stage is yours.
Thank you. Thanks for having me as a keynote speaker. So I want to ask you guys a question. And before I ask it, let me just kind of explain. I've been doing this stuff for a very long time. This stuff is not new. I was there 25 years ago when the whole semantic web thing got started. And but even longer than that, I've been looking at our industry as a whole and how we do data. And I'm not happy with the current state of things. Like you heard, I'm from Amazon Neptune. Neptune is a graph database. This talk is not about Neptune, and it's more sort of my personal reflections and somebody might say frustrations, my observations about what's going on. So this is my question. So will knowledge graphs save us from what I perceive to be kind of the mess of modern data practice? And of course, I'd like to say absolutely yes. But that would make a very short talk. So, okay, we're done here. Thanks for coming. So let me answer this way, and we'll revisit this question at the end. But for now, let's say it depends. And so this talk is going to be basically two things. I'm going to talk about what I perceive to be a problem. And then I'm going to talk about how I imagine what the solution could be. And I don't have all the answers. But let's say that I sort of want to get you guys thinking about what the real solution actually could be to the issues we have in our industry. So a lot of you here are probably interested in the idea of getting rid of silos. I keep hearing that a lot, and so let's talk about silos a little bit. So silos are everywhere, and I take a little broader view of what a silo is. So obviously, every time you define a new data model, it, logically speaking, is a silo, because the way we tend to do things traditionally in this business is that the data models don't really talk to one another. Same for APIs. Every API is kind of like a new vocabulary that the interface talks to this black box where the data is. And then furthermore, every presentation of data, in a way, is a silo as well. Because oftentimes, because everything else is a silo. Now, when you're whatever system you're using, and that presents you data in some ways, and you have very little control over that. So in those ways, it is a silo. And when I look at what's happening, it's like we spend an awful lot of time just converting data, moving data around, converting it from one format to another. We massage it, we clean it up. So this is kind of like the current state of things. And if I look at like really sort of grassroots level practitioners who have to deal with data, whether that be like accounting data in a company, financial data, or whatever, it seems that Microsoft Excel really is kind of the dominant data tool of our age. People keep putting data in an Excel spreadsheet and massaging it and mailing them around and whatnot. Okay, so, but anyway, silos everywhere. So I think that this is what we have. So this, of course, is the Tower of Babel, Peter Bruegel's painting. And it's like everybody's talking, but nobody's understanding. And I think that's sort of the key issue, is the understanding. Where is the meaning of things? So I kind of divide this up into what I refer to as 3 S's. So here are where the problems lie. So software, silos, and semantics. And it's very clear that these are not unrelated things. So then there's this, the modern data stack. And every week when I read about the modern data stack, it's somehow different. You know, well, every day, yeah, exactly. So, oh, the horror. I really honestly don't want to hear about the modern data stack. It's, and then the word stack. I mean, it's not a stack. We say stack because we want to sound like we have our stuff together, you know, like we know what we're doing. But it's not a stack. It's just a collection of tools that we're supposed to use. And every day, every week, there are new tools, and I just don't have time or the energy or the motivation to all the time learn what new tools have shown up. So we're very tool-oriented. There's this constant stream of tools. And of course, you know, maybe, you know, the conspiracy theorist in me says that new tools, you know, that supports a very vibrant service economy, because somebody has to be able to know how these tools work. But in some ways, these tools, when I look at them, either they fix some small problems, or I look at it, it's like a Band-Aid over something, or then it's just kind of like a new layer over something where the problem is actually deeper. And, you know, we have issues with APIs too, and APIs are often seen sort of as a panacea, you know, hey, you know, we just have APIs and all the problems are solved. But not so, because APIs, they are silos as well. And so the software industry, of course, wants you to think that, hey, let's add more software. We'll fix it. But I don't think the software industry has a particularly good track record in dealing with complexity, honestly. I think we need less software, not more. But we keep doing the same thing, you know, and the problem doesn't get solved. So silos, okay, so data is locked behind an API or an app, you know, you have to play by whoever's rules to get to the data. Integration is always an engineering proposition. It leads to, you know, some kind of bespoke solution. It would be nice if we could eliminate silos, obviously. And it's not a technical problem alone. In fact, it's very little a technical problem. We know how to do it. But it's more sort of a people problem, organization problem, process problem. And one of the things I've learned over the years, that if you go and you try to start doing this, you know, it's like, oh, let's have shared data models. Let's have an upper ontology. Let's have it span the entire organization. Invariably, you're going to step on somebody's turf. And then all this sort of territoriality or whatever it's called comes up. So if you want to do it, you have to be diplomatic. Oftentimes you work with people who don't report to you. You have no control over these people. You have to somehow motivate them to do what you want. You become like a volunteer organizer. Okay, so semantics. I mean, obviously we've heard this term a lot over the last few years, and I find it ironic that most people who say the word semantics don't actually know what it means. I don't take any kind of sort of formal or philosophical view of what semantics is. I like to think of semantics as definitions of how data behaves. and how a software system should interpret data. And of course, today we do it by hardwiring it inside a black box. And that's not good. How do you define and communicate semantics? And how do you inject semantics into your data that supposedly has semantics, but you can't get to it, or whatever? Shameless plug here. Juan Sequeira and I, we have written a book, and it talks about how you inject the semantics into your data, and it talks about the people and process aspects of building knowledge graphs and moving from data to knowledge. And so after my talk, if there's time for questions, the first 5 people who ask a question get a copy of the book. And Juan and I will even autograph the book. Okay, we'll see if we have. We'll see if we have time. Okay. Okay, and then comes my really favorite part of this problem, is that people tend to confuse formal semantics, formally defined semantics, with their own interpretation of what the data means. So I will illustrate this, and I will use JSON to illustrate this. These are the kinds of things I hear all the time. People say, my data model is JSON. Any of you heard that? Any of you said that? So JSON is not a data model, mind you, okay? And it has no semantics. So then they say, my data is just JSON. And I guarantee you, your data is never just JSON, because you always impose some external semantics, some outside interpretation to that data, and therefore it is not just JSON, there is this external thing. Okay, and then my absolute favorite, JSON is easy to understand. Okay, so let me illustrate that, okay? So here's a little snippet of JSON, right? Okay, you guys can all understand that, right? Yes? No? Yes? Easy, right? Okay, I'll show you another snippet, and in fact, it has the same meaning. You still understand this? I think there's one person besides me here who understands this. Okay, so I call this the weak crypto mode. Okay, so the key is known, right? But almost nobody has it. So obviously, these things are spelled out in Finnish, and but the meaning is the same, you could argue. And so we need to get beyond this. We need to get beyond that. You look at the data and you go, I understand this. That's fine if you think you understand it, but the machine will not understand it. And that's the key issue here. All right, so enough with the problems, right? So one of the things I've heard in this conference about all these new technologies, and this is still young stuff, and we're early in this stuff. So let me take a sort of a slightly longer term view of these things. We can go at least back to the 1730s to look at this stuff, both graphs and ontologies. So it's actually interesting that I think it was the same year that Leonhard Euler published his first work on graph theory, and Carl Linnaeus published his work on the taxonomical classification of plants and animals. I think it was 34 or something like that. So anyway, fast forward, 1950s, we established this thing called computer science, and graph theory in many ways is sort of the essential underpinning of computer science. 1960s, sociologists realized that, hey, we can use graphs, and gives rise to social networks, the so-called small world experiment, Erdős numbers, and all that stuff. And then, of course, 60s and 70s, we start having network-based databases, semantic networks. So now we're starting to spill over to the ontology side. 1970s to, let's say, 1990s, we also established predicate logic as sort of the core foundation of knowledge representation. And so then these things come together about 25 years ago in what we now refer to as the semantic web. And semantic web is the underpinnings and the origins of modern knowledge graphs. So this is not new. We've done this stuff for a while. So let's look at this now. And when I look at this, I think here we actually did have the right idea. Okay, so now you guys are going like, semantic web, seriously? Right? That's what this guy's going to talk about again, you know? Seriously? Very seriously. I'm very, very serious about this stuff. We did have the right idea. We have been doing this for quite some time, and those of you who haven't noticed, you need to just pay more attention. There's a lot of stuff that's very mature at this point, that's quite usable. So why do I find these technologies attractive? So here's my short list. And the first one is absolutely the most important thing. We have self-describing data with accessible semantics. We can move data around, and the semantics, the definitions can follow around, or we know how to get to them. And I already said this yesterday, but you know, when people say accessible data, you know, make data accessible, you know, give me access to your data. Oftentimes they mean, you know, I want the physical bits. And if you do just that, you're not doing any service to whoever you're giving the data, because those bits are not useful unless they understand what the data means. And now we come back to the, you know, what is your personal interpretation of that data? And, you know, mind you, you know, your personal interpretation of whatever data I give you might be different than my personal interpretation of that data. So it's important that when you give people data, you also hand over the semantics. Semantic web technologies let you start defining semantics, not by code and inside applications, inside black boxes. It represents a move from procedural way of doing things to more declarative way of things. And then there is kind of this interesting serendipitous aspect of the semantic web. You don't always know that there are more questions that you can ask of your data representation that you originally thought. Now, of course, many of you have heard me talk in the past, and this sort of about how graph-based representations are really intuitive, and may have heard my anecdote that I titled, I can explain this to a 7-year-old. So I'm not going to repeat that. This is about me explaining to my 7-year-old daughter at the time what my PhD dissertation was about, successfully. So there's actually a sequel to that anecdote, and the new anecdote is titled, "I've polluted an innocent young mind," because the daughter is now 21. She's a computer science undergrad, and she told me that she just got 100% in a final where the last question was, given this edge-weighted undirected graph, demonstrate how to compute the minimal spanning tree. 14 years later, when I first started explaining this, so I've you know, all hope is lost. She's gone, you know, she's deep into graph theory now, and that stuff. But who knows? My explanation 14 years ago, what did that do? I don't know. But it became clear to me 14 years ago that this is an intuitive way to think about the world, to think about data. And then finally, we built these technologies on a well-understood, widely deployed, robust infrastructure and technologies. Semantic web originally, many people said, oh, it's new vision for the web, or it's knowledge representation for the web. But it's more like knowledge representation using web technologies. So I'll pick these two things, accessible semantics and graph-based representation. And I think that those could get to us something that I think of as a unifying language for data. That's what we need. We don't need more tools. We need this common unifying language that allows us to talk about data, allows us to talk about the meaning of data, and allows us to kind of ship these definitions around to others who want to use your data and your knowledge. So this is what I want. Semantics is really the key thing here. We need this unifying language so that we can formally define semantics. So it's no longer about some person's interpretation of what the data means. And now, of course, since I talked about the semantic web, now some of you are thinking, oh, but RDF syntax, you know, what the heck were those people thinking? Syntax does not matter. Anybody who tells you that syntax is important is just flat out wrong. Just forget syntax altogether, completely. Just do it. Syntax is not important. It's a completely solved problem. We don't have to think about it anymore. The real problems are higher up in the stack, and that's actually a real stack. I think that RDF&OWL are our best candidate for this unifying language today. I am more than happy to welcome some other language if it's better, but none has shown up for the past 20 years. And then, of course, you know, I'm talking about graphs sort of as a logical construction here. So I work in a graph database team. I like graphs. I like graph databases. But if you want and you need to keep your data in some other physical form, that's fine. We understand quite well how to map, let's say, relational representations to graph representations. So that's also not that big of a deal. Another thing we need these shared definitions of things. And I think that there's going to be a panel later today that Dean Alemang is running exactly on this on this topic. So there already are some nice shared ontologies and shared definitions. What I really wish is that the open source community would embrace this the same way they have sort of embraced the idea of crafting software. So that's one of my calls to action here. So finally, we're not done with problems yet, so it turns out. So graph is a graph, right? But we have this rift in our community, and it's hurting us. RDF versus labeled property graphs. I hear this conversation all the time. Now, with the Neptune database, we have chosen to support both because we want to give customers the choice. And we do that. That's absolutely a good thing. Customers need to be able, users need to be able to choose which kind of graph representation they use. But when we give them the choice, the problem is that this is like the law of unintended consequences. They're going to exercise that choice. And they get confused. Which one should I use? Well, what I really would like to say is that it doesn't matter. And all this talk about this rift is just hurting our community. So just stop. Don't talk about it anymore. Let's move forward. So we have a project in our team that we call OneGraph. And the idea is to have a graph model or meta model that accommodates both of these. So, you know, someday when we're done with this, I can run Gremlin over RDF or Sparkle over property graphs and things like this. Now, it's not easy to get there. There are challenges. We have a paper from last year that's sort of like a catalog of challenges. W3C is working on this thing called RDF Star. We're participating. It has been a community group until now. It's going to there's going to be a chartered working group soon. So I urge all of those of you who think that this is important to really get involved in that. Now, all of this said, I think that the real issue here when we look at these graphs is this, what I've illustrated here at the bottom. So on the RDF and OWL side, we think of data as sort of a logical construction. RDF and OWL allow us to do logical models of data. But on the LPG side, the graph is really a literal data structure. And you write code to manipulate a data structure. We know how to do this. I mean, this is what we've done for decades. And I think this is the big thing that we have to kind of overcome, and we're working on that. So let's revisit this question. I do think we can solve this mess. We move from data to knowledge, and we focus on semantics. And I believe the answer is this unifying language. It's not a new tool. But of course, maybe I don't have all the answers yet. So let's go with this. We can find a path to happiness here, but it's not an easy one, and it's not a quick one. There will be some pain. And importantly, the technical solutions, they do exist, but we now need to work on people and processes and those kinds of things. Anyway, thank you. And I will take some questions, but before I take questions, our business development person has informed me that there is a special conference offer. And we're offering 100% of $100 worth of AWS credits if you want to try Neptune. So I'll just leave that there.
Thank you, Aura.
Yep.
Thank you. So we have 2 minutes for questions.
Okay.
So that is going to be fast. I'm seeing a lot of book interest. I think, Jay, you were the first.
Yeah. All right, thank you. I think I really like your statement about we need to unify. We should not talk a lot about, RDF versus property graph. But anyhow, my question is, what do you think of the biggest barrier for people to adopt RDF? How do we make it simpler for any normal people to adopt? It's like you say graph is simple for 7-year-old. Is RDF as simple can be for 7-year-old to understand?
Yes, it is. And there are technical details, obviously. And those technical details are not important for the 7-year-old or for most people who use RDF. And we can have tooling, we can have user interfaces that hide those details. Those details are not important from the user standpoint. They're highly important from the standpoint of how RDF works. And things like triples. Okay, so triples are important for 2 groups of people. People who care about formal semantics, truly care about formal semantics, and people who build RDF databases. Nobody else should care about triples. It's like programming in assembly language. So,
thank you, Aura, for your talk. The conversation can continue here and on Slack.
Yep.
There are questions online if you want to check it out as well. But thank you again for your talk.
Thank you.